Welcome back, physics fans. We're talking a little bit today about heat transfer rates between two objects. So if I did something like taking a hot, reservoir of some kind and connected it through some, solid object or something to, or it doesn't have to be solid, I guess, to a cold reservoir. How would heat transfer through here, right? Because it's going to transfer that way. But how much and how fast? Well, we have a simple equation that we have to deal with that. I'm going to bring it over here so I can look at it to make sure I don't get it wrong. And that's delta Q over delta T is equal to some conductivity constant times the area times the difference in the two temperatures divided by the length of the thickness of the thing separating them. So let's write that down. And K is going to be thermal conductivity. And that's different for each material. So if I were to stick like a brick in the middle, it would have a different conductivity than if I stuck an iron rod, right? I think that's pretty straightforward. So if I wanted to do a problem where we said something like, I don't know, you want to design an experiment with some sort of insulating rod between them of an unknown thermally conducting material. If the rod is 1 meter long and diameter equals 2 centimeters, and then we'll say the temperature of the hot thing is, 350. And the other end is touching the surface of some ice, I'll say. So we'll say this is ice or something. So this is going to be T. We know that we'll just say the ice is kept at 273 Kelvin. Because that's going to be the temperature at which ice freezes. So, how much heat would go through per second? Well, you can figure out area through pi r squared. We can take delta T and say that's going to be, 67? We can, but we don't know K, right? We know L, so L's 1 meter. So we have to get some more for K. So what if I had some graph that it gave me, that looks something like energy transferred by heating, so let's just call that Q over time, and it's going to look, and we'll scale this, so at 5 seconds it's going to be a little over 12. Let's call it 12 and a half. So what is the thermal conductivity of the rod? Well, I know that delta Q over delta T, the slope of that thing, is ballpark 12.5 over 5. And I know that's going to equal K times, well, I guess let's just solve for K first. K A delta T over L. So can you see this still? Let's check my thing. Yeah. So delta Q over delta T times L divided by A delta T, equals K. So that's going to be my slope of my graph. I think that first one's supposed to be an A. There we go. The slope of my graph times L times pi times d over 2 squared, because it gave us diameter, not radius. I'm using diameter, times delta t is k. So now just put numbers in, and I'll get back to you with that answer. You know what? I'll let you do this for the rest of it yourself. The exercise is left to the student. All right. I'm going to call that one a short video. I'll see you in the next one.